Hi, everybody. Hope you are all doing well. I am out today, but this is going to be the quick instruction for today's assignment. It builds off what we did last Thursday, in terms of taking linear graphs, equations, and tables and putting them into some sort of context. So if you remember, we ended with the panda problem, looking at the table versus the graph to make comparisons between two pandas. That's kind of what we're going to do with these problems is take a situation and create a table, equation, and graph. So if you open the document that's attached called Linear Equations in Context, and you can pause if you need some time to open that, we're going to start off with the sample problem. So this is the one I'll go through just to show you kind of what the expectations are. So each problem will start off with a scenario. So in this sample example, we have a streaming service that charges a $5 membership plus $2 per new movie streamed. So the first thing we want to do is identify our independent and dependent variables. This is just another way of saying what does X represent and what does Y represent. We can type right into the doc. We can do X, and that is always our independent variable. And in this case, X would represent the number of new movies streamed. And then we have Y. So we have a membership fee plus all the new movies we stream. That is going to equal the total cost. So I've identified what my variables are. And if you think about independent versus dependent, if you can state the X and Y in terms that it makes sense, like the total cost is dependent on the number of new movies streamed. The number of new movies streamed is not dependent on the total cost. So I've got my X and Y, and then we're going to create a table with at least 5 values. Now remember, we're using a context. So if X is the number of new movies streamed, X cannot be negative. So I'm going to start my table at 0. And I also cannot have fractional movies. I'm going to make it nice and simple, just do 0 through 4. So if I don't buy any movies, I'm only paying the membership fee. That would be $5. If I buy one movie, that would be $5 plus the $2 for the movie, giving me a total of $7. If I buy 2 movies, that's going to be $4 plus my membership is going to be $9. And now I see a pattern emerging. 3 movies will be $9 or $6, sorry, plus the 5 would be $11. And 4 would be $8 plus the 5, which would be $13. So now looking at my tables, I can check to see if I have a rate of change. So each interval for Y is going up by 2. For X, it's going up by 1. Remember, everything is Y over X. So my slope is going to be 2 over 1. My y-intercept, if we remember from the table, is wherever x is 0. So that was where I started. So the y-intercept will have a value of 5. I can now write the equation for this line. Y equals my slope times x plus my y-intercept. So I have my table, I have my equation, and now I'm going to head over to Desmos to graph the line. So I want to graph the equation. So when I go to Desmos, I want to put in that equation, y equals 2 divided by 1x plus 5, and you'll see we get a line. I want to go into the graph settings so I can put labels in. So let's slide me over. So my x-axis, we said that was the number of new movies streamed. And on the y, we said that was the total cost. And again, I want only what's in quadrant 1 because I can't have a negative number of movies. And they're not going to pay me, so I don't need a negative cost. So I'm going to take this to -1 just so I can see the axes. And on the y-axis, again, I'm going to go from -1 and I'm going to go up to 10. The step tells you what to label the axes. So you'll see right now it's only doing every other number. If I want to do steps of 1, that will give me every number. And then to insert this back into my doc, I want to share the graph. You can copy the link if you choose, or we can export the image. This will bring up a picture of our graph. And I can copy the image by right-clicking and go back to my document and paste it back in. So I can see my labels on my axes and my graph clearly on my coordinate plane. So that's what we're looking for, to turn a problem that has a context, identify what we're looking for in the variables, create the table, use the table to create the equation, and then insert a picture of the graph. I'm just going to delete that for space. So you're going to have 3 problems to work on. The first scenario is Molly earns $8 an hour at her job. Your second scenario is that to join a dancing club, there is a $30 startup fee and a $4 monthly fee. And the third one, Tom wants to lose weight. After exercising consistently for 3 weeks, he has lost 15 pounds, now weighs 228 pounds. So those are all your scenarios, which you'll need to identify your variables, create a table, equation, and graph. And then the last is your transfer problems. So again, refer back to problems 1, 2, and 3. Number 1, how much will Molly make if she works 40 hours a week? So we're using what we got to predict. Number 2, how much will it cost to join the dancing club for a year? And number 3, how much will Tom weigh after 8 weeks? So do your best. You may work together if you guys want to set up a FaceTime or something like that. Or if you're in person and want to work together, that is fine also. Hope you have a great day, and I will see you on Thursday.